All right, so the goal of this video is to establish the general form of a conic section, but in polar form. And it turns out that there's a lot of similarities between them looking at their equation. But if you think about how a conic section behaves in relation to its directrix, they all kind of look the same if you zoom in close enough. And this is an example here. You know, that blue curve is the conic section. It could be part of an ellipse, it could be part of a hyperbola, it could be part of a parabola. The key thing is it always looks kind of the same. It's always going to be opening away from its corresponding directrix, so that's where we start. So we have a directrix whose equation in rectangular is x equals k, and it turns out that for any conic section, this quantity is always holds. PF over PD, so PF is the distance between any point on the conic and the focus. PD is the directed distance from the point on the conic to the directrix. Remember, with a parabola, those were always equal, so that ratio would be 1. So it turns out that if it's always the case that PF over PD is equal to eccentricity, which we talked about in the first half of this section, then that means you definitely have a conic section. So we're going to use that to establish the polar form. So here's what we're going to say. The focus is always located at 0, 0. So that's going to be our new vantage point there, okay? So that means that if r comma theta is a point on the conic, so I'm going to call P r comma theta, that means that PF is equal to r. So we have r over something equals E. Now, as far as PD, which is this distance right here, well, this distance here is k, right? So I need to figure out what this distance is right here, which is, we'll call it FB, but you notice it's already labeled as r cosine theta. It's the horizontal side of that right triangle that's there. So that means that PD is k, which goes all the way out, minus r cosine theta. So there we have our equation. So now all we have to do is solve it. So to solve it means to solve for r. So I'm going to multiply both sides by k minus r cosine theta. So when I do that, I'm going to have ek minus er cosine theta. I'm going to bring the r terms to one side. I'm going to factor out the r on the left-hand side because my goal was to get r equals. And then I'm going to divide both sides by 1 plus e cosine theta. So you have r equals ek over 1 plus e cosine theta. So looking at a conic section in that form, notice we didn't specify which conic it was. If it's written in that form, I can easily identify the eccentricity and I can easily identify where the directrix is. So this is beautiful stuff, okay? So now going to the general equations from the book. Now this was one specific case where the directrix was to the right of the focus. So that means that this first one, so right of the focus means I'm opening this way and there's my directrix. In the second box, so the directrix is left of the focus, which means we're opening to the right. Now keep in mind the things that are here. Notice there's a minus here. And notice that the numerator is negative as well. In fact, we're going to address that and just quick spot check. All of my numerators are either positive KE or negative KE. So we're going to get to the bottom of that. Okay. If we have a directrix that's above the focus, so something like this means that the conic has to be opening down. And naturally, this means that this should be opening up. There's the focus. So you notice that it's going to be easier to remember these formulas by two things. If the directrix is left or right of the focus, it's cosine. And remember, cosine was the x-coordinate going back to trig. So there's that connection. If it's above or below the focus, then it's a sine, okay? And I do have a typo here. This last plus should be a minus. I'm just going to fix that real quick. Now I want to address the numerator. Notice it's either positive or negative KE. Well, if it's left of the focus, that means K is negative, right? So the key thing to remember is that the numerator is always positive. And the reason for that is when k is positive, it's ke. When you're above the focus or to the right of the focus. When k is negative, you're putting a negative in front of it, which makes it positive times the eccentricity. So that means the numerator is always positive. So there's an overview of the 4 forms. I encourage you to try to derive it yourself. It might be a little difficult, but hey, go for it if you want to. When we get back, we'll look at some specific examples. So thanks for watching and stay tuned.